Hello and welcome to the UMUC Statistics 200 Week 3 video. I'm going to cover two topics this week. One is expected value. How do we fill in a probability table, calculate the gain or loss? The second topic is binomial probability distributions. What are the arguments or variables, as another way to say an argument? How do we find those and evaluate the distribution? And how do we calculate the probability of events using this information? So let's first start with expected value. Here's the problem we're posed with. We have this fundraiser that we have an option to buy a ticket for $20. There's 100 tickets to be sold. They're going to give away one prize for $1,000 and 5 prizes of $100. So there's a total of 4 winners. So if you think about it, the charity is going to make $500 because they're going to take in $2,000 and pay out $1,500. So we ask ourselves, what is our expected gain or loss for playing? And we're going to assume that we're purchasing one ticket. So here's how we do that. We need to create a probability distribution table, and the variable we use, we're going to call this X, and it's the net gain or loss. So we always need to consider the price of the ticket. So this is how we set up the table. There's certain things that have to add up in the end. The first thing we do is we describe all the possible outcomes. So in one case we have the loss of purchasing a ticket, and another case is we win prize number 1 or we win prize number 2. And so in the case where we lose, in that case we lose the cost of the value of the ticket, which is our net gain or loss is $20, and there is a 94% chance of that occurring. The reason it's 94%, 94 out of 100, is because there's 6 chances out of 100 to win, because there's one prize of 1,000 and 5 prizes of 100. So out of those 100 tickets, 94 of them will not win. So we take the minus 20 loss, multiply it by 0.94, and this is our expected gain or loss in this last column. We do this for each case. Now let's look at the first prize. In the case where you win $1,000, your net gain is actually $1,000 minus the cost of the ticket. So your net gain is $980. The probability of that occurring is 1 out of 100, so I multiply by 0.01, and I get an expected gain of 980, 9.8. We do that for the second prize, $100, cost of a ticket's 20, so the net gain or loss is 80, but there's more of a chance to win here, so there's 5 out of 100, or 0.05, so we take 80 times 0.05 and we get 4. In the end, what we need to do is sum up this entire column on the right, and we get a total of minus $5, and this is our expected gain or loss. So let's see what that means. What that means is we should expect to lose $5 per every ticket that we purchase. And this makes total sense, because if you think about it, if they're selling 100 tickets and the expected loss is $5 a ticket, then everyone will lose a total of $500. So you got 100 tickets, each one's going to lose $5 in the hands of those people. So the loss is $500, which is exactly what their profit is. And I stated that up in the original problem. So this is how we do an expected value problem. Let's go down to the next one, which is binomial probability distribution. This one may be a bit more confusing. So let's take the case here. I'm a golfer and I'd like to analyze the probability of a golf pro hitting a green in regulation with his approach shot. So on average, we know that pros hit the greens 64% of the time, and there's 18 holes in a round of golf. So if we are asked, letting X be the number of greens hit in regulation, we assume a binomial probability distribution. What are the arguments and the variables here? We need to know the number of trials, the probability of success, and the probability of failure. We also want to find the probability of that a golfer hits 9 or fewer greens in a round. And lastly, the probability that a golfer hits 5 greens in a row. So let's think about each of these cases. So in the first one, the solution is relatively simple because we just base it on the given information. The number of trials in this case is 18 because there's 18 rounds of golf, or 18 holes of golf, and that's how many chances we get to hit a green. The probability of success was given at 64%, so we say that's 0.64, and the probability of failure is 1 minus the success rate, or 0.36. So these are numbers we need to use in the binomial probability distribution. So now how do we find the probability a golfer hits 9 or fewer greens? We have to use this pretty funky probability distribution. And it's a fairly complicated formula, but here it is, where n is the trials, and this little exclamation point is factorial. If you're not sure what that is, look that up on the internet and see what factorial is. And then p is the number above, q, and all the other variables are described here for you. So in this particular case, what I'm going to do is show you the long way of doing this and show you how I use Excel to do this. I prefer to use Excel. It is a lot easier, but you can do this by hand also. So if we use the regular equation, here's how we do it. The probability of x equals 0. We have 18 factorial, 18 minus 0, 0 factorial, and basically we calculate all this big long term and we get this answer. Now we have to do it again for x equal 1, we have to do it again for x equal 2, and we have to keep doing this all the way up to p probability of x equal 9. So we're basically evaluating all 9 of these cases separately, and then we add up the answers in the end to get our final answer. So it's possible, it just takes a lot more math. But let me show you an easier way. Here's how we do it in Excel. If you go check out my Excel tips file, it will help. So we do, in Excel, we use this function here, binomial distribution, where I need to know the number of successes, the number of trials, the probability of success, and then the cumulative says, do I accumulate 1, 2, 3, 4, 5, 6, 7 all the way up to 9, or am I just looking for the individual one? And in this case, we want the cumulative, right? We want to go all the way 0 all the way up to 9. So this is how we do it. This is the function I put in Excel right here. And my final answer is 0.16, real simple. So there's a 16% chance that a golfer hits 9 greens in a round. Let me show you real quick what that looks like in Excel. And here's the case. So I pulled up an Excel file, and you see right here, if you turn on your view and you view the formula editor, you can see the binomial distribution. So I put in 9. I've got 18 total trials, and I've got a 64% probability, and 1 because it's cumulative. And whoops, I'll go back, and there's my answer. So if I want to do that again, remember to enter an equation in Excel, I put an equal sign, binom distribution, parenthesis, and then it starts to tell you what it's looking for. So let's just say we wanted to do 2, 18, 0.64 success, but if I just want the value for 2 alone, 4.97, 10 to the minus 6, let's go back to what we had. And if you look up here, the probability of 2 is exactly that, 4.987, 10 to the minus 6, that's the answer. So if I wanted to do cumulative, I'd have to put a 1 at the end of that, and that would be the addition of 0, 1, and 2 all added together. So the very last thing is, what's the probability that a golfer hits 5 greens in a row? This one's a bit different, so we've got to think about 5 consecutive events where the probability of each event is independent, and it's a 64% chance. So basically, the chance of hitting the first green is 64%. The chance of hitting the next green is 64%. The chance of hitting the next green is 64%. So if I'm going to do that 5 times in a row, my answer is 0.64 to the 5th power. And that little caret sign is a power. So you can think about it as raised to the 5th power. And when I do that, I get 0.107 or 10.7% chance. So that basically says a pro has a 10% chance of hitting 5 greens in a row. It basically means they're gonna miss a green fairly regularly in 5 in a row. So that's all for this week, and thank you for listening.